The idea of a knowledge ecosystem is an approach to knowledge management which claims to foster the dynamic evolution of knowledge interactions between entities to improve decision-making and innovation through improved evolutionary networks of collaboration, in contrast to purely directive management efforts that attempt either to manage or direct outcomes. Knowledge ecosystems espouse that knowledge strategies should focus more on enabling self-organization in response to changing environments. The suitability between knowledge and problems confronted defines the degree of fitness of a knowledge ecosystem. Articles discussing such ecological approaches typically incorporate elements of complex adaptive systems theory. Known implementation considerations of knowledge ecosystem include the Canadian government. Key elements to understand knowledge ecology as a productive operation. It is helpful to focus on the knowledge ecosystem that lies at its core. Like natural ecosystems, these knowledge ecosystems have inputs, throughputs and outputs operating in open exchange relationship with their environments. Multiple layers and levels of systems may be integrated to form a complete ecosystem. These systems consist of interlinked knowledge resources, databases, human experts, and artificial knowledge agents that collectively provide an online knowledge for anywhere anytime performance of organizational tasks. The availability of knowledge on an anywhere anytime basis blurs the line between learning and work performance. Both can occur simultaneously and sometimes interchangeably. Key elements of networked knowledge systems include core technologies. Knowledge ecosystems operate on two types of technological core, one dealing with the content or substantive knowledge of the industry, and the other involving computer hardware and software and telecommunications, that serve as the procedural technology of operations. These technologies provide knowledge management capabilities that are far beyond individual human capacity. In the business education and training context, substantive technology would be knowledge of different business functions, tasks, processes, products, R&D, markets, finances and relations. Research, codification, documentation, publication and electronic sharing create this substantive knowledge. Communications between computers and among humans permit knowledge ecosystems to be interactive and responsive within the wider community and within its subsystems. Critical interdependencies. Organizational knowledge resides in a complex network of individuals, systems and procedures both inside and outside the organization. This network is established in the form of social and technological relationships. The relationships reflect vital interests and mutual histories. The elements of the network are dependent on each other for resources and mutual survival. Accessing and using this knowledge network involves understanding and maintaining the integrity of underlying relationships. Knowledge engines and agents. This refers to the system of creating knowledge including the research and development processes, experts, operational managers, administrators, software systems, archival knowledge resources and databases. Performative actions. Organizational knowledge is converted into economic value through processes that involve action. These could be cognitive actions such as learning or deciding, or physical actions such as preparing a meal or writing a check, and social actions such as organizing or entertaining. Organizational tasks most often require all these and other types of actions to occur in a linked way for value to be created. They occur in the physical spaces, electronic spaces, economic transactions, and communicative exchanges of knowledge tasks. They contribute to achievement of organizational goals. See also Notes. Further reading. Klippinger, J. ed. The Biology of Business, Decoding the Natural Laws of Enterprise, San Francisco, California, Jossey Base, 1999. March, James G. A Primer on Decision Making, 1994. March, James G. The Pursuit of Organizational Intelligence, 1998. Malhotra, Yogesh, 1999. Knowledge Management for Organizational White Waters, An Ecological Framework. Knowledge Management, 2 6, 18–21. Poor, G. 2000. Nurturing Systemic Wisdom Through Knowledge Ecology. PDF. The Systems Thinker, 11 1–5. External links. Tim Clark 2006. Knowledge Ecosystem Task Force Proposal, W3CHCLS SIG Draft for Discussion February 13, 06. https://web.archive.org/web/20090412025302/http://wiki.nasa.gov/cm/wiki/federal%20 knowledge%20 management%20 groupment20 group%20 opening parenthesis KMWG closing parenthesis .wiki/1001884 main_bontis%20 from %20 km%20101%20 slides.ppt https://web.archive.org/web/2008-10-10_meeting/2008-10_presentation.pps Zhuge H. and Shi, X Toward the Eco-Grid, a harmoniously evolved interconnection environment. Communications of the ACM, 47 9, 2004-78-83.